Okay, this is lesson 8, section R.7, radical expressions. And radicals can be looked at as like the opposite operation, like multiplication and division are opposite operations, addition and subtraction are opposite operations. Understanding a radical expression. Given a radical expression, where we have this outside number here is the root. Normally, square root, we think of, we don't normally put a 2 there, but it's implied that whatever squared, like if we had 9, square root of 9 would be whatever, 9 is the same thing as 3 squared. So, we don't normally write 2, and then we normally just write it as a square root. We don't normally put a 2 there, so it's implied that it's a 2. But anything else, like 3 would be cube root and so on, fourth root. The x is called the radicand. Okay, that's the number that's getting applied, in this case, the square root or whatever root you have. The square root of a number is one of 2 equal factors whose product is the number. So in other words, 9 would be like 3 squared. So the square root of 9 is 3. So here we have a negative outside the radical. So we think of 81 as 9 times 9 is 81, right? So the square root of 81 is 9, but we have a negative outside there, so it would be a negative 9. Now here we have a negative inside the radical. And we cannot say negative 5 times negative 5 is negative 25, right? Because it's negative 5 times negative 5 is a positive 25. So there's nothing squared that can give us a negative 25. So that would be considered not a real solution or not a real number. And that gets into the following lesson where we get into what's called imaginary numbers. So we can't do anything with it. If it's an even root, like square root, fourth root, sixth root, cannot get a root inside there. It's not real. But odd roots, like if this was a cube root of a negative 8, well, negative 2 times negative 2 times negative 2 is a negative 8, right? So the odd roots are okay. We can get a real solution from that. But it's just the even roots we cannot. Okay, those are going to be not a real number or not a real solution. More properties of radicals. And that's what I was talking about here. If the root is even, then we cannot get a real solution. And that's what I was saying here. Negative 25 squared is not the same thing as negative 25. Or negative 5 squared. Not the same thing as negative 25. But cube root of a negative 125 is negative 5 times negative 5 times negative 5. You can get a negative 125 from that. So you can get a real solution, which would be negative 5. Converting from radical to rational exponents. We're not going to be doing this too much, but it's kind of nice to know this. The m outside, that's always going to be the numerator. The root is always going to be in the denominator. Whether it be the m be outside like this or inside the radical, it's still going to be looked at as m over n. Okay? And when we get into more with working with radicals inside exponents, especially inside the radical, this can be helpful. Okay, properties of radicals. We'll come back to this one after we work some problems. Okay? So let's take a look at our Okay, so if we were to say, if we're given the fourth root of x to the fourth, okay, this would be like saying x to the 4 over 4. In other words, the exponent that's outside is going to divide into the exponent that's inside. Okay, so that's where I was showing you those rational exponents, where you change from radical to exponential form. So you're actually dividing the exponent, and you just get x to the first, or just x. Okay, so let's say that we have something with some additional terms to it. Like, let's say that we have this. We've got the fourth root, and then we've got 81. P to the 12th, Q to the 4th. Alright, so we want to ask ourselves, you can look at this in this way. You can say, alright, this is the fourth root of 81 times the fourth root of p to the 12th times the fourth root of q to the 4th. Okay, now you want to ask yourself, what to the 4th power is 81? Well, we got 2 times 2 is 4, times 2 is 8, times 2 is 16, right? What? That can't be it, so it's not 2. Well, what about 3's? 3 times 3 is 9, times 3 is 27, 27 times 3, that's 81, right? So we can say, all right, that's 3. And we can say this is p to the 12 divided by 4. And q to the 4 divided by 4, right? So this can be 3 p to what power? The third, right? Because 4 divided by 12 is 3. Q to the first, or just q? And that's our answer. So you don't necessarily have to divide it like this. You don't even have to split it like this. But you want to think in terms of 8 divided by 12, p to the third. 4 divided by 12, it's p to the third. 4 divided by 4, that's going to be q to the first. Okay, so you can do that, and that's something that you can do mentally in your head without any problem, and not present too much of a problem. Okay? Alright, questions with that? Alright. It helps if you make a table for yourself, such as 2 squared equals 4, so therefore the square root of 4 equals 2. 3 squared equals 9, so the square root of 9, of course, is going to be 3. 4 squared, 16, so the square root of 16 is 4. 5 squared, 25, so the square root of 25 is 5, and so on. And you do 6 squared, 36, and you just keep right on going. 7 squared, 49. And so if you do this little table for yourself, you know, it might be helpful for you. 8 squared is 64. And then 9 squared, 81. And then I'm not going to, you know, you guys get the idea with the square root. 10 10 squared is 100. 11 squared, 121. Excuse me. 12 squared, 144, and so on. 13 squared, 169, and so on. Okay? Usually you don't have to go too much further than 13. Okay, so that's squared. Well, what about cubed? Same thing. 2 cubed is 8. So cube root of 8 is 3, and so on. 3 cubed is 27. And so cube root of 27 is, this is 2 up here. This would be 3. 4 cubed, 64, and so on. 5 cubed is 125, and so on. Just keep on going down like that. And that would help to kind of, work through these problems as you're working through them. Come up with like a table for yourself. All right, any questions with that? Okay, so if we had the cube root of 216, okay? Well, if we said 5 cubed is 125, 6 cubed just happens to be 216. Okay, so we can say here that cube root of 16 is going to be what? 6, right. Okay, well what about the cube root of a negative 125? Well, what times itself 3 times?
5.
It's 5, right? But we got a negative here,
-5.
so that's going to be negative 5, right? Because negative 5 times negative 5 times negative 5 is negative 125. All right, good. Well, what about the 4th root of a negative 216? How about that?
-6.
It'd be what?
6.
No, it's all
Negative
from
six.
3.
Yeah, it's the 4th root. And so, can we say something times something 4 times? We can't, right? Because it's an even root and we got a negative inside, so therefore it's not a real. They may say real solution, but it can also be not a real number. Okay? Either one, real solution or real number. It's not real either way. All right, questions with that?